Okay, so in this class, we'll discuss question 68, cases 1, 2, 3. So let us read the question once. With a neat ray diagrams, state the position, nature, and size of image formed by convex lens in each of the following cases. We'll discuss case 1, 2, 3 first. So let's take case 1. Okay, case 1 is when write down object placed at infinity, so very far from the mirror, from the lens. Okay, now remember this as we draw. Listen carefully to the first one. Here, draw a line sufficiently long, and then in the middle just draw a line 3 centimeter up, 3 centimeter down, or 2 up means 2 down, equal. Okay, and then mark here this point as your O. Now take any distance you like, maybe 3 centimeter with your scale. Maybe mark 3 centimeter. Okay, and then the same distance you mark here, 3 centimeter on the left also. So this distance 3 means here also 3. That should be very carefully noted. After you mark those points, remember this: the ray that comes here, this side will be taken as first focus, this side will be taken as f2. Now I want to explain something here. In the case of mirror, we know that a mirror can reflect only from one side. So it has only one focus because it cannot reflect from both sides. But lens is not like that. In the lens, you can see that both sides can reflect light. You pass a light ray on this side, it can refract. If you pass a light ray on the other side also, it can refract. It has 2 refracting surfaces. Mirrors have only one reflecting surface, but lenses have 2 refracting surfaces because it's transparent both sides. This side also you can pass light ray, and then this side also you can pass. That's why we have 2 foci plural. But mirror only one side, therefore mirror has only one focus. But lenses can refract from both sides, so we should have 2 foci. But even though it can refract from both sides, sorry, we have to keep something else in mind. So before that, you complete the lens. This is convex, so convex is thick at the center and thick at the center, thinner. This is convex. Draw that. Now the object is at infinity. So even though it can refract from both sides, right also, left also, we'll always put object on the left. Okay, that means if I want to form the image of a tree, I'll put my convex lens and my tree not on the right but on the left, that side, left, just like mirror will follow. So here it does say this lens here, this one is focused towards a tree very far from here, that is called infinity. So you will know that in our mirror also we discussed rays coming from infinity, or 3 at infinity, 5, 6, 7, 8 rays, whatever comes out. But because it has long distance to travel, after some time all of them become parallel to each other. So incident rays coming from a tree at infinity always come parallel to each other. So keep that in mind. Let's keep that in mind. Now here, in this one, okay, just rub out with your rubber. It'll be better to put here F2 because you need space down, sorry. So here you draw your image first. For the first case, it's easier to draw the image first. So this is the image. Okay, and then you pass a light ray through the optical center, brushing the top of this image like this. So left side is the incident ray after passing through lens is the right side emergent ray or refracted ray. But in this case, it will not bend because it's passing through. Oh, we know the rule that any ray passing through optical center will not bend. We have learned that, right? So do that. Then, since the next ray, we need only 2 rays to get an image. So the next ray also will come parallel to the first one, because we know rays coming from an object in infinity come parallel to each other. So we can write here parallel incident rays from an object at infinity. We mean to say these 2 rays are coming from the object at infinity, therefore they are parallel. Okay. Now after passing through the lens, every ray bends except the one going through the middle. So let it bend and go to the top of the image like this. Mark the refracted ray here. For now, don't forget to put there. arrow. So the two refracted rays meet here and form the image here. So if we write the thing here, we write here image is the same position first, so formed exactly at f2, isn't it? F2 is here, exactly at f2, and it is on the right side, so we will write behind, and in bracket you can also add it, right behind the convex lens. That's the position. Then the nature is, these are formed by real rays. That means the image is real and it is ulta, so it is inverted. Because it is formed by intersection of real refracted rays, it's real image. That's the technical definition. But practical term is, if you put this lens here towards the tree at infinity, that means the image is formed, image of the tree is formed on the right side. So you won't get this side, you will go this side. But you will not see until you bring a piece of white paper or cloth, means screen. And when you're exactly here, then you'll see the image of the tree on the screen. So because it requires a screen to receive it, therefore it's called real inverted image, because real images are always received only on a screen. Virtual image don't need a screen. Example, as I said, the image formed by the looking glass at home. You don't need any screen, you see directly behind mirror. That's virtual image. Here we won't see the image unless you bring a screen and put it here, and the image will be formed on the screen. That's why it's called real inverted image. Okay, and then the size is much smaller than the real tree, so it will be highly diminished. Keep this in mind. So the real inverted image here is formed behind or right side. Please note the difference here. This is where many students get confused. In the case of mirror, real inverted image was on the left side, in front. But real inverted for lens is always on behind or right side. That's the difference. If you know that, the sign convention is same. Many students get, as I said, confused because of this. Real inverted image formed by lenses are always on the right side or behind. But real and inverted image formed by mirrors are always on the left side or in front. Keep that in mind. You will remember that, right? When we did mirror, all the real inverted was on the left or in front. But in the case of lens, all real inverted image will be on the right or behind, okay? Now, let us go to case 2. Now the case 2 is object is placed beyond twice f1. Beyond twice f1. If you don't understand, it's okay, just wait, you'll get it. Twice f1. So let us draw that. Case 2. Here, draw the line like you did just now. By now you're getting it. So in the middle, you just draw a line up and down, same distance. And then here, maybe 2 centimeter. 2 centimeter is a good distance. 2 centimeter. Okay, 2 centimeter. 2 is a good distance. Okay, so there 2 equal. This 2 means this is also 2, I mean. The side also 2, then 2. This 4 should be equal, okay? Otherwise you won't get a good diagram. So 2, 2, 2. Do that first. And mark this side here, F1, and here, F2. Now this is 2 centimeter, means 2 means double. So this will be 2F2. This side 2 and 2, so this will be 2S1. That's what we mean by beyond 2F1. Now you complete the lens. Convex, so just draw the convex lens. And middle point we know is optical center. Oh, mark it. Then the object is placed beyond 2F1. So properly beyond, not too near. Like this, don't go too near, otherwise you won't get good diagram. Here, you draw your object. So this is your object, let us say top of the object, bottom of the object. Let us say a burning candle or your thumb also. So this is your object. If you like, you can write it down. Now to get the image, we need 2 refracted rays. So from the top of the object, let us imagine a light ray is coming parallel to principal axis. As we said, we will always put the object on the left, just like a mirror, even though we can put on the right also for lens, because it can reflect that side, but we won't do that, okay? So the rule for this one is any ray parallel to principal axis will always, after passing through lens will refract and go to the focus. Here, F2, exactly. I repeat, any ray parallel to principal axis will refract and go to the focus. That's the rule. Okay. Now we need at least 2 rays, refracted rays, to get an image. So pass from the top through the optical center. We know the rule, so pass it there. There, a ray passing through optical center goes straight without any bending. So let it go. 1 arrow before lens, 1 arrow after lens. Now where these 2 cut on the right side is where the image is formed. So there, I draw the image. So this is the top of the image, A dash, B dash, because this is coming from the top of object. So this will be the top of the image down now. So this is your image, right? So we write down image is formed where? Between F2 and 2F2. So we write here formed between F2 and 2F2. Let us do that. And comma behind or right side of behind the convex lens. You see, it is real and inverted, just like the first one, and it is smaller than object, so this time it will be diminished, right? So that means you won't see the image. The lens is like this. This is the lens. Then you put a burning candle here, you will get the image on the right. See, so you won't see because it is really inverted, so you need to bring a white piece of cloth screen. And when you're between F2 and 2F2 only, you'll see the candle image on the screen. That's why it's really inverted. Okay, then here, just notice here, even in the first case, real inverted and behind or right. Here also real inverted, behind or right. So it's settled now that every real and inverted image for lens will be behind or right side. Okay, case 2. Then case 3. Let us go to case 3. So here case 3 will be object placed exactly at 2F1, let us say 2F1, the third case. So here let's draw the lens like before. Here you draw a line like this, and then here draw the middle line, and then 2 centimeters is enough, I think. So 2 here, 2 here, 2 here, and here also 2. Mark those points, F1, 2F1, and for this one here, don't mark this one. For this case, this is easier like this. Mark only this one, F2. Okay, then put your object exactly at 2F1. Okay, before that, complete your lens. This is the convex lens. So here you mark your O. This is your object A, B, object. That's it. Then from the top of the object, you pass a ray parallel to principal axis. This is the incident ray. This will bend and go to the focus, so let it go to the focus. Do it like this. Refracted ray. You know the rule. A ray parallel to principal axis will go to focus after refraction. Then you need 2 rays, so pass it through the optical center, and you know this will go straight without any bending. Let it 1 arrow before lens, 1 arrow after lens. Let it cut the first refracted ray. So where they cut, you draw the image, and then extend it slightly above the line. This is the top of the image, A dash. This is B dash, image, and write this one finally to F2. That's easier, okay, in exam also. An object is at 2F1, image will also be 2F, exactly at 2F2. Keep that in mind and it will be easy to draw. So formed image is formed exactly at 2f2, comma, behind or right side of the lens. Real inverted still. That means you'll have to put a screen here, then you'll get the image. Otherwise you won't see the image, because real image can't be seen unless on a screen. And the size is not diminished, image is of the same size as the object. So the same size as the object. So this is case 3 completed. I think we said case 1 to 3, but I think 4, 5, 6 also can complete your object placed. Okay, between 2f1 and f1. Okay, 2f1 and f1. So let us do that. Here, draw the line too slowly, sufficiently long. Middle one you draw, and then take 2 centimeter again. Maybe here 2, and then here 2, here again 2, then here again 2. Like this you mark f1, 2f1, f2, and here 2f2, 2f2. So to complete your lens here, this one and this one, an optical center O. Object is between 2f1 and f1, so 2f1 is here. Between that you place your object. Medium size is okay. Object AB, let us say. So we can write here, if you want, object. And we need to draw a ray parallel from the top, one ray, incident ray come, then up to middle of lens, and we know the rule by now, it will bend and go to the focus, right? So draw, don't forget to put the arrow. Then another ray is needed, so let us just pass it through the optical center and continue to draw till it cut the first one. One arrow before lens, one arrow after lens. This ray will not bend because it's passing through O. Any ray passing through O never bends, right? So continue to draw the first refracted ray because it's too short till it cuts this other one. So we need to draw this line longer, so we draw it longer, and here is where the image is formed. So you draw the image. So this is the image, top of the image, A dash, B dash. So this is our image that is formed. So you can write it down. So here now, image when the object is between 2f1 and f1, between 2f1 and f1, image is formed beyond 2f1. So we write it beyond, formed beyond 2f2, sorry, beyond 2f2, behind or right side of the lens still real and inverted. And now the image is for the first time bigger than object, so we write there magnified, right? This is case 4. Okay, so case 4. So again, real inverted is on the right again. Case number 1, 2, 3, 4 are all real inverted and on the right. So lens is like the real inverted image is always formed on the right for lens, but real inverted image is always formed on the left for mirror. That is the confusion point for many students, so keep that in mind because we need that in numericals. Otherwise you will solve your numerical wrongly. Okay, now next here, case 5. 2 more cases to go. Object placed exactly at f1 now, at f1. So let us draw the line. Write that one down by pausing the video if you want and come back and join. Now here. Now this time draw the middle line. And then maybe we can take a little bit longer because we need space, I think 3 centimeter, 3 here. And here also 3. We don't need 2f1 and 2f2, so just write here f1 and f2. That's enough. And draw your lens, convex lens or middle point. Our object is exactly at f1. So there, put an object medium sizes. Maybe make sure this is 3 means this is also 3. Okay, you can even take 2, but we're just taking 3. Okay, up to you. I'll draw a ray from the top of the object parallel to principal axis. We know that this will go to the focus, so let it go to the focus. Draw it carefully. A reflective ray. We need 2 rays, so from the top pass it through the optical center. Interestingly, you will find that this ray goes to the optical center, means it will not bend, and you find these 2 rays are never going to be, they are parallel. It should come out parallel, right? So that means if it is parallel, the image is going to be, these 2 parallel rays will meet only at infinity on the right side. So they will meet, but very far from this lens on the right side. So formed, you can write here, at infinity, but still behind or right side of the convex lens. It will be really inverted, and the size will be so huge, highly magnified. So in a sense, just to make us understand, that means if you put your thumb here, the object, the image of your thumb will be very far from here. This is the lens, means hundreds of kilometers from here. Where you put a screen, then you'll get a big thumb, maybe the size of 2-3 story building or something like that. Just for imagination's sake, highly magnified, so big, right? So by now, case number 1 to 5 is all real inverted and form on the right side or behind. Lens is like that. The last case is different, and we'll do that. So here now, case 6, object placed between F1 and O, between F1 and optical center. So this one is important. This is the only one that is different, which is not really inverted. So now, draw the line, draw the middle of the lens. Take 3, 3 again will be a good distance, 3. Here also, this time also 3. Here mark F1, here mark F2. Draw your convex lens, complete it, mark your optical center. And properly between F1 and O, you place an, don't place it too big, medium size or small rather, object. So this is a rather small object. Top is A, bottom is B, let us say. And draw a ray from the top of the object parallel to principal axis. Incident ray. So object should always be placed on the left. Let us say this is your thumb or candle. Now we know this will bend and go to focus, so do that. Like this. We need 2 rays, right? So we'll find that. Complete that first. Okay, complete that. Then here, pass it through the optical center. 1 arrow before lens, 1 arrow after lens. Don't forget that. 1 arrow before lens on the left, on the right, 1 arrow. Every time there should be 1 arrow on the left, 1 on the right. Otherwise your mark will be deducted. Now look at the 2 refracted rays. They're never going to meet because they're diverging on the right. They're never going to meet on the right side. That means the image will not be formed on the right side this time. It will be on the left. How? Okay. Produce the rays backward. So if you produce it backward, just produces the longest one, and the other one also same straight line. It should be on the same straight line. Produce it backward like this. This one back, 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 back. This also same straight line with broken rays and meet here. So they meet here and form an image. For me, it's here just beyond this one, but yours need not be here. Even if it's here, it's correct. As long as it's behind the object. Here doesn't matter, okay? So don't bother. Here A dash and this one B dash. So this is your image. This is a very different image from the first 5 cases. So this time we will write here, image is formed here behind object, just like a boy standing in front of another boy. See, this is the boy in the assembly and another boy behind him. So formed behind the object, but it is in front, behind the object, but in front or left of the convex lens. For the first time, we're seeing an image is formed on the left side or in front of the lens. Every image was really inverted on the right. Now this time it's not formed by real rays, by broken rays. So this time the image is virtual for the first time and erect. That means we will not need a screen, we'll see directly. And the size is bigger. See, can you see the image is taller than object, so magnified. This is the only case where the image is virtually erect and it is in front or left. The first case 1 to 5 was real and inverted on the right or behind. That's how lenses form images. Okay, so here, this is the case. See here. If I put my thumb here, can you see? From the camera, I hope you can see. There you see a big thumb. There you see my thumb is big or not. Let us check. See, the real thumb is only this much, okay? Then when I put the lens, you see a big thumb, right? See, there. Because my thumb is between P and F, sorry, O and F1 and O, very close to the lens. You can see my image of my thumb. If I remove it small, if I put big Z, big thumb is this one. This is the real thumb. This one, this real thumb is this, AB. And then the one you see right now, bigger thumb there, is this. Both are on the same side, right? See, so same side, virtually, right? You can see directly. That's how we do it. 6 cases for formation of image by convex lenses. Case 1 to 6. Case 1 to 5 was real inverted behind or right side of the convex lens. The last case 6 was the only case where virtually erect. It was in front or left of the convex lens. Keep that in mind. Okay, so this concludes the class.